Hey, this is Sue. We're going to talk about part of handout 3-1. So what I'd like to do is, if you haven't already, I'd like you to guess the derivative for these three functions. We've talked about this in the last unit, so go ahead and pause and try to do that. Okay, now that you're done, what I want to do is use the limit definition of the derivative to check what you have, because what we've been doing has been very informal and we need to be a little more formal now with this. All right, so let's go back. Let's do the first one. Our limit definition says that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. So in this case, if f of x is equal to 4, well, let's skip to the second part first. What is f of x? Well, f of x is 4. What is f of x plus h? Well, f of x plus h is also 4. F of anything is 4. So this is 4, and the bottom is still h. So what we get here is the limit as h approaches 0 of 0 over h. So here's a quick note. Is this going to be 0 over 0? Is this an indeterminate form? Okay, so you've talked about limits of 0 over 0 in the past and how that's indeterminate. You have to work on that. This is not a situation where the top is getting closer to 0 and the bottom is getting closer to 0. This is a situation where the top is already 0 and the bottom is not yet 0. So that's actually quite different. Okay, so I'm going to say that again. The top is already 0 and the bottom is getting closer to 0. So what we can do here is, without taking the limit, we can simplify this internal expression. So I'm simplifying this to get 0. So the key is realizing that you're actually taking the limit of a constant function. And that limit, of course, is 0. So that's our answer. Hopefully you guessed that one right. Let's do the next one. Okay, so again, we know that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. So let's set up the quotient, and then we'll simplify, and then we'll take the limit. So again, I'm going to start with f of x first. F of x is equal to x. That's what function we're doing. What is f of x plus h? Right? Now, if you're not sure, let's just go over here and make sure we're okay with this, right? So f of x is x. You could even warm up. You could say, like, what is f of 8? It's 8. You could say, what is f of heart? It's heart. And what is f of x plus h? Well, it's f of x plus h. What is f of x plus h? It's just x plus h. And that whole thing is over h. All right, so let's simplify that. And the top simplifies quite nicely to h over h. And as we said in the previous example, you don't need to take the limit yet. So let's just simplify that expression. H over h is 1. And then the limit of the constant is just 1. And again, hopefully you knew that. Let's do the third one. So let's do the derivative for this third example. And again, we'll start out with f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. And you know, sometimes people spend a little time ahead trying to figure out what f of x plus h is. So let's do that on the side again. So if f of x is equal to 4x, right? And so we know you can put anything in there, like f of 2 would equal 4 times 2, and f of x plus h would equal 4 times x plus h. Some people find this helpful to write this out. Some people don't need to write this out. You will find what works for you and helps you be the most accurate. So when we substitute up here, we get the limit as h approaches 0. And here's our f of x plus h. It's 4 times x plus h minus f of x, which is 4x, over h. There's a little more simplifying here. You actually get to distribute. Woohoo! And again, there's some subtracting in the numerator. That cancels out. And so we do a little canceling of the h's. And again, we have the limit of a constant, which is just equal to 4. You're going to see this over and over again, that the h's are going to cancel out. In fact, you should look for that. Hopefully, these were relatively easy, and this helps you just review this limit definition of the derivative and helps verify what your answers were. Okay? Thanks.